Hi, I'm Hui.
Hi, I'm Eileen.
I'm Richie.
I'm Alan.
Hi, I'm Daryl.
First part of our assignment, we'll be using Python to crawl data from HungryGoWare. First, we'll use link crawl, which is shown on the screen, to get the URLs of different restaurants in HungryGoWare to a text file. Now we'll show an example of the process. So all the data will be dynamically loaded, and after loading, we will start to extract the URL of those restaurants into a text file. And next, we'll use a crawler to crawl through those URL in a text file to extract the reviews of those restaurants. And after extracting the reviews, we will construct the XML parser to pass through the XML of the restaurant reviews and get the reviews from the document. We will be processing the data by only getting the ASCII formats. And after this is done, we will use the NLTK tokenizer to tokenize the string, and then regular expression to further process the words. The resulting words will be stored into a corpus, and the answer for question 1 will be shown in the screen.
The work to back deep learning. The 5 keywords that we have selected are healthy, delicious, service, quality, and ambience. For our work to back model, we actually use this script file here, which takes in our text corpus and output this work vector file as shown here. After the file is trained, we can use it to find similar words, and these are some examples. This is our keyword, healthy, and these are some similar words.
3. Internal annotation agreement. Our group picked 300 reviews and it's split into 3 as shown. The group will produce resultant annotation for S1, S2, and S3 as shown. From the resultant annotation, we produce the following result. The I1 and I2 difference of 0.02 can be contributed by I1 having one less disagreement as compared to I2 as shown. Even so, we determine that excellent internal annotation agreement as both kappa value are more than 0.75 by a large margin.
For opinion mining engine, we used NLTK's naive-based classifier in Python. For the features, we used bigrams from our dataset. To run the naive-based classifier, each review must first be organized into individual.txt files and put into a negative or positive folder depending on its sentiment. Next, we run the code. Here we have our code. This is the function to convert our tokens into bigrams. And here we have our data split into subsets S1, S2, and S3 to train and test accordingly. And finally, when we run the code, the program will display the results of the accuracy, precision, recall, and F measure.
Part 5.5. We first populate 3 text files. The predefined feature sets, which is from the top 50 informative features we got from part 5.4. Next, the word to vec feature set from the 5 distinctive words we use. And lastly, the random data set we got from the knowledge base. Then we train and test the data set with only the given features from each set, and the result is as shown. Next, we use the deep learning extracted features with logistic regression, and the result is as shown. Lastly, as you can see from the first part, information features extracted from a knowledge base could improve the accuracy of the dataset, but it is subjected to the context of use.
For past text creativity, we are proposing the following ideas. We intend to split emoticons and emojis into 3 classifications as shown, and process as following. We also have the idea to use 5-step scaling as compared to 2 steps. The proposed 5-step scaling is more detailed than current scaling and more accurate. However, we do not intend to implement the more complicated 200-step scaling, as still will complicate the process of annotation. We also sought to use dynamic ANN by using TSK fuzzy model as shown. The model will help us in interpreting the additional inputs and allow us to obtain the outcome of sarcasm detection and improve accuracy. Ultimately, our entire NLP report allows us to have this following impact.